Hello there, today I will be showing you how to use Orange data mining program. But first, what is data mining? Data mining is about discovering previously unknown relationships among data. It is a multidisciplinary skill that uses machine learning, statistics, artificial intelligence, and database technology, and more. There are a lot of techniques in data mining. We will use linear regression and the prediction in our work. Now, when we come to the Orange, what will we do and what will we need to know about Orange? I can say Orange is a program that's used for compare data to two and use that data sampler and the remaining data to find if the data target is as it's supposed to be or there is an anomaly with our data. But this was just the aim and the result. Now let's start from the beginning. Here's our file that I have found from the Kaggle. There are 5 columns in it and a lot of rows in it. First, I will give these columns their roles. From here, file. To success in our data, we should give them the right type and right role. In the real life, we are using region and the state to categorize some place. So we are giving them as a type categorical. And the categorical types are being as role the feature. Cases is a numeric thing. So it's as rolling the feature. That is also numeric and it is also feature. Date is text and it is rolling meta because it is independent from these things. It is just happening whatever you do. The days are coming and going anyway, whatever happens in the world. So it is meta. But in the Orange now I'm trying to find how many dates. So I'm giving the dates the role targets. I will use region feature, state feature, cases feature, date meta, and a sampler of dates feature to find the remaining data from that targets. And now we will use scatterplot. With scatterplot I can see my file more clearly. And what is this? There is something wrong with my data, which I did on purposely. Now I can show you what to do in this condition. We will open a process and in it we will select impute missing values. There is 3 options, all of them works, but now for coronavirus data I will do remove rows with missing values. And now when I go on I will see that the problem is gone. Well, in the scatterplot I can see it more clearly as I said. Look at the cases and look at the dates. How that goes normally to upside. Alright, now let's delete this. For now I will not work with it. When we contain, I can select rows from here. Which what will I do is selecting conditions. As states, I want my state to be one of AC and AM. And as date, I want it to be before 2020. I won't use it too. Select columns, which I will not use it too for now. But you can see what to do in it, right? If I want the region to be ignored, I'm selecting it and putting it to here. If I want meta to change, I'm selecting it and changing it. I can change the target. I can do stuff I also can do in file. And now we will use rank to see which one of those features in the starting I used is more important for finding our targets. In here we can see cases, region and states, and to make linear regression we will need numeric data. So region and state is not numbering, we will only use cases and I'm selecting cases, that's all. Now we will make a data sampler, which is the thing that we are trying to do from the beginning. In the data sampler, we can split our data to 2. I will split it to 70 to 30 And the orange will use that 70 to finding the 30. That's the thing I said at the beginning. It is using a sampler of data to finding the targets. Well, it's 70-30, so sample data, and let's go on. We will use linear regression units, and to see what our linear regression did, we will need a data table. In data table, we can see our equation, and now it's time to make a prediction. When we making prediction, we will use not data sample to data, we will use remaining data to data, and for comparing that two, we will draw a line between linear regression and the prediction. And now it is over. With predictions, I can finally compare the real data with the linear regression's data. In this, I can see the dot numbers and how they should have been in linear regression. It's like that, we did it. And here I can see our coefficient of determination, aka our success, our 0.8, which is pretty successful if you ask me. The closer it gets to the 1, the more successful it is. So this here is a success if you ask me.